Okay, so we've got Descartes' rule. I'm not gonna sit there and read all of this to you, but, so I'll just kind of get into it, but you probably do wanna like make sure that you read through that. But it lets us know what what the signs are gonna, it lets us predict what's gonna happen with the equation based on the signs. That's really what it has to do with. So what we're gonna look at consecutive coefficients have opposite signs. And so when this happens, it lets us make a prediction. So what we're looking at is, we're just looking right here. So from here to here, from here to here, from here to here, from here to here, from here to here. All right, so if we look right here, this one, I have a sign change. This one, I don't have a sign change here. I do have a sign change here. Here I do have a sign change. That one changes, and then from here to here changes. So if we change, we're counting the alternating signs. Are y'all okay there with what we're doing? Okay, so what this says is the number of positive real zeros is equal to the number of variations in signs. So here, my variation was 3, right? I changed signs 3 times. So this would be either 3 or 1. So you're gonna go down by 2 each time. So like if I had 5, it would be 5, 3, or 1. If I had 4, it would be 4 or 2. Y'all okay there? All right, so the number of negative real zeros is equal to the number of variations in signs. All right, so we'll kind of talk about what that means in a minute. Okay, so the rule of signs, repeated zeros are included, therefore a 0 with a multiplicity of m is counted as m zeros. We'll talk about what that looks like as we get into it. All right, so if we get down here in this first problem, I've got a sign change here and then a sign change here. So that tells me that the number of positive zeros is going to be either 2 or it could be 0. And if you think about where we did our P over Q, our options are 1, basically plus or minus 1 and plus or minus a half, right? Like those would be our 2 choices. And so if I either have, if positive 1 works, then that would mean positive 1/2 would also have to work. Because if I have 1, I either have 0 or I have 2. I can't just have 1. Does that make sense to y'all? Okay. So then f of negative x, or my negatives, I have to have a total of 3 zeros, right? So we're going to kind of prove this. So if I switch my stuff, I'm going to have negative 2x cubed plus x squared minus 2x. There's no x here, so I'm not changing the sign on my 1. Are y'all okay with what I did? I just basically multiplied all my x's times the negative. Are y'all good? Or I made every x negative. You're all right with that? Okay, so then when I look at these, I have, this is a negative and a negative. I have negative and negative, no sign change. So I only have one sign change right here. So my negatives is 1. So if my negative is 1, then that means my positives must be 2, because I have to add up to 3. Does that make sense? So when you have that, like when you look at that rule, it allows you to know like what you would need to synthetically divide by. Like if you didn't have your calculator and you were having to do the synthetic division, you have to choose what to divide by. You know there's only one negative. So if negative 1 didn't work, then negative 1/2 would have to work. Does that make sense to y'all? Yes or no? Yes? Okay. All right. Let's see. Let's go down to 4 because it's kind of a longer one. Are y'all okay with that? All right. So if I look here, I've got sign change there, sign change there, sign change there. That stays the same. Sign change there. So it looks like there's 4. So for my positive options, could be 4, it could be 2, or it could be 0. So if I do f of a negative x, then if I make this negative, then this will be negative x to the 5th. negative x right here to the fourth power would end up being it would still end up being a positive x with the negatives out front. Are y'all okay there? So I'm still gonna get negative 2x to the fourth there. Here, when I put in a negative x, this one's gonna become negative because it's odd. So minus 3x to the third. Here, when I put in a negative x, it's gonna become positive. Oops, sorry, I switched on. This one becomes positive, but the negative's still out front. This one's gonna change to 4x, and the 8 is gonna stay. We do have to account for the constant also on your sign changes, so if you don't have a constant in your problem, then you would need to just do a plus 0 at the back. Everybody okay there? But you need to put plus 0 at the back. Alright, so here, no sign change, no sign change, no sign change. Looks like there's just 1. So for my negative, it's just 1, which means it has to be 1 and 4. Everybody good with that, with how that works? So you would know what to synthetically divide by, yes? Okay. Quick note, like add a, like a plus 0 if there is no constant. Because that would account for a sign change, so we do have to make sure we verify. Alright, okay there? Yes, no? Okay, so let's go back here and see. Y'all are okay with just counting sign changes? I'm not gonna do that a bunch of times unless y'all are comfortable. Everybody's comfortable? Make sure on one like this, where you had the negative, you would account for the fact that you would have like a negative. Then when I put in the negative x cubed, this one would stay negative, so you'd have the double negative, you'd end up with a positive x cubed. Are y'all okay there that would happen to you? Just kind of watch your signs on those. It's just something that you have to be careful about. Alright, so how can we use this? So let's go back to what we did yesterday. So we're going to count our p over q. So I would have plus or minus 1, 2, 4, and 8, right? Like those are my options, because the first thing it says is list all the possible rational zeros. Since my leading coefficient is 1, all of those are over 1, so I don't have any fractions. So I have 8 possibilities of what my factors could be. So then they want us to check the positives and the negatives. So we're going to look for the sign change. So looks like just one sign change. So positive is going to be 1, which means the negative it should come out to be 3. It would be 3 or 1, but if we have a total of 4, it's going to have to be this. Is that logical to y'all? Okay. We can prove it by doing f of negative x, but a lot of times you can prove it without. This one would stay positive. This one would become negative. This one would stay positive. This one would become positive. And that would stay the same. So we would have sign change there, sign change there, and 1 at the beginning to there. So it ends up 3 and 1 is what we get. We just proved that it is 3, but it's relatively easy since the positive is only 1. So sometimes you can just use process of elimination. Alright, so since there are more negatives than positives, I would probably start with a negative because it's more likely that we're going to get one first. Does that make sense to y'all? So I'm not going to start with positive 1. I'm going to start with negative 1 because it's more likely for me to find a negative. So I'm going to start with my negative 1 to synthetically divide. 1, 6, 7, negative 6, negative 8. Bring this down. Negative 1, 5, negative 5, 2, negative 8, which gives me positive 8, nothing left over. Alright, so now I've got x cubed plus 5x squared plus 2x minus 8. There's not really a factor by grouping that's going to help me here because the 5 and the 8 don't really match up. So factoring by grouping won't work. So I would go to synthetic again. Alright, so again, there's more negative options than positive, so I'm going to go to negative 2. Y'all okay there? now I've got, looks like x squared plus 3x minus 4, which I can factor pretty easily. X plus 4 and x minus 1. So I ended up with x is equal to, it's going to be 4, it's plus a 1. So I had both positive and negative 1 there. I had negative 2 here and negative 4. Okay on that one? And if we look at 10, my factors of 4 would be plus or minus 1, plus or minus 2, you don't have to plus minus 2 down, plus minus 2, and then plus minus 4, and then if I put P over Q, okay, I think we're good there. Oh, we can also have half there. Alright, so positives, let's see, no sign change, no sign change, no sign change, no sign change. So my positives are 0, which means negative could 4, 2, or 0. Obviously, it has to be 4. So they're all going to be negative, which means I wouldn't divide by a positive at all, because it doesn't make any sense. Logical to y'all? I can tell you that negative 1 doesn't work. I've already tried it. So we're going to start at negative 2, because I know negative 1 doesn't work. So we'll divide by negative 2 first. Again, I'd be okay if you check your graph and got the other pick one, but you do need to know how to determine the signs. So I've got 2, 15, 31, 20, and 4. So negative 4, gives you 11, negative 22, gives you 9, 15, gives you 2, negative 4, 0. Okay. So now we've got 2x cubed plus 11x squared plus 9x plus 2. Okay, so I can tell you also divide by negative 4 doesn't work, but negative 1/2 does work. I've already checked it, so you can see it in your calculator. So if we're dividing by negative 1/2, or that would be, essentially that would be 2x plus 1. Are y'all okay that it's 2x plus 1? So I'm going to use long division to divide by 2x plus 1. I'm going to do it over here. So I'm going to divide by 2x plus 1. 2x cubed plus 11x squared plus 9x plus 2. And 2x and 2x cubed is going to give me x squared. So that gives me 2x cubed plus 1x squared. But remember, we make the sign changes there. So it's going to be 11 minus 1, which is going to be 10x squared plus 9x. 2x into 10x squared is going to give me 5x. I'll multiply back through 10x squared plus 5x. I'm going to have a sign change here, so that gives me 4x plus 2. So then that's going to be a plus 2 back there, which gives me 4x plus 2. And when I make the sign change, everything cancels. Okay, so now I've got x squared plus 5x plus 2, which does not factor. Y'all are okay that that does not factor, right? So if I have a quadratic that does not factor, then that means I'm going to have to do the quadratic formula. So I've got negative 5 plus or minus square root of 5 squared minus 4 times 1 times 2 over 2 times 1. Okay, so when we simplify all that on the radical, it gives us negative 5 plus or minus the square root of 17 over 2, which doesn't simplify. And if I calculated these out, both of these would end up being negative. So even though we have the plus or minus there, like this whole thing, it nets you a negative number. Are y'all okay that that's what happens there? Alright, so we would have x is equal to, we did -2, we've got -1/2, and we've got -5 plus or minus the square root of 17 over 2, and that takes care of all four. Those don't happen real often, but they can.